Hi guys, today we are solving both two problems here. One is lead code daily problem and one is GFG daily problem. And lead code, coming to the lead code problem, here the problem is leaf similarities, and the problem statement is they are given with two nodes, two roots, root 1 and root 2, and we have to find the leaf value sequence of two roots. Like for suppose the leaf value sequence of root 1 is all the leaf nodes coming from left to right, so in a sequence. And if the if you consider this as a root sequence, like 6 7 4 9 8, it is coming from left to right, in a sequence of the order. So exactly we have to consider the same sequence for root 1 and root 2, and we have to check the values of the root 1 and root 2, and we have to check the leaf node values of the root 1 and root 2. If they are equal, then we can consider that they are a leaf leaf similar trees. So in that case, we need to return true, or else we need to return false. So for for this problem, I have used the DFS algorithm to go along the tree and find the leaf nodes here. For that, I have used the list to store the leaf nodes of root 1 and list 1 to store the leaf nodes of root 2. A leaf node is a node where its left and right values are equal to null. So this is the basic condition here, and yeah, I have applied the basic condition. Whenever I hit that condition, I need to store into the list, considering it as a leaf node. So after doing the DFS algorithm for both root 1 and root 2, we are with list of leaf nodes, right? Now we have to check whether they are leaf similar trees or not. For checking that, first of all, we need to consider the size of both list of size and the list one dot size. If they are not equal, then we can say that they are not similar trees, right? So in that case, we need to return false here. So if they are equal, we need to check the values of both the indices. If the values of both the indices are equal, then we can return true, or else we can return false here. So this is how I solved this problem here, and the time complexity of this problem is big of n, where n represents the number of nodes in a binary tree. Okay, and space complexity is the height of the tree. Yeah, thank you. Oh, and coming to the GFG problem here, the GFG problem is search pattern KMP algorithm here. Like they are given with two strings here. One is pat strings, that is pattern, and the text strings geeks, and that is the main string here. We need to check the occurrences of patch string in text string, and we need to return the indices of that occurrences. Like for suppose, if we see here, the patch string is geek and text string is geeks for geeks, and from 0 to 0 1 2 3, from 0 to 3 there is a match of patch string here, so we need to return here. So and we need to not just return the index here, we need to return one based indexing while returning the indices here. Like for suppose, if the from 0 to 3 the index g has a pattern here, index 0 has a pattern here, in that case we need to 0 plus 1. Yeah, and this is a simple uh, sliding window concept here. And I've considered two pointers of ij, and uh, I have considered a value as I, and the flag which tells whether there is a pattern or not, and b equal to 0 here, and r- ran a loop inside the another while loop for checking whether there is a pattern from I to j or not. If there is a pattern from I to j, then we need to return. There is a pattern in the pattern from I to j, then our flag will equal to be 0. It says that there is a pattern. If the flag is equal to 1, it says that there is no pattern, there is no such pattern in this range. So if the value of flag is equal to 0, then we can consider that there is a pattern here. So we can store into our list the index of the occurrences of the pattern. So in this way, I have solved this problem here. And coming to the complexity kind of thing here, the complexity is big of n here, and the uh, space complexity is big of n here. Like for considering and worst case, the space complexity will be one, will be n here, because if the value of pat is z, and the all the like if the pat value of the length of pattern string is 1, and the text dot string has all the characters equal to uh, pat characters, then we can consider that the space will be uh, big of n here at worst case. This is the worst case here. And coming to the time complexity, big of n here. And this is how we solve this problem here. And thank you.